For these problems, 10, 11, 12, and 13, we're going to use this rule here that x to the negative n equals 1 over x to the n. And this tells us a lot more than it looks. It says that if we change the sign of the exponent, we can change the position of the base. So we can move bases from top to bottom in a fraction if we just change the sign of the exponent. Let's do that in number 10 here. So in number 10, we've got negative 5 to the negative 3. This is going to give us 1 over. Now drop that negative 5 into the denominator, right? Change its position from the top to the bottom, but you have to change the sign of the exponent. This will give us 1 over. Now negative 5 cubed is, I'll write it here so we can see it. Negative 5 times negative 5 times negative 5 is going to be 1 over. We've got 1, 2, 3 negatives, so it's going to be negative, an odd number of negatives. So it's going to be negative 125. And in number 11, we have 2 to the 12th divided by 2 to the 9th. Now this is a division. We're going to use our quotient rule for this one. So we're going to write this as, here's the quotient rule. If you have x to the n over x to the m, a division, you subtract the exponent. So it's x to the n minus m. So, right, because we talked about this a couple sections back, if you're doing a division, here's a globally, I have a division, and right below division in our order of operations is subtraction, right? Let's just review that for a second. The order of operations goes like this. You do, as you look left to right in an expression and compute and simplify, you do powers first, then you do multiplications and divisions, then you go back left to right and you do addition, subtractions. And one operation applies to the one directly below it. So look what we have here. We have a division. So you look over here, what's below division? Subtraction. So that tells us to subtract the exponents, the top minus the bottom. So back over here, we got two powers with the same base. I'm going to subtract the exponents, the top minus the bottom. So I end up now with 2 to the 12 minus 9. I get 2 to the third, and 2 to the third is 2 times 2 times 2. That's an 8. Now, in number 12, we have a division. I'm going to do this one two ways. Here's one way that we could do this. I have a division, so I'm going to use this division rule. I have a quotient, so I'll take the top exponent minus the bottom. That's going to look like this. 5 to the negative 4 minus negative 7. Be careful with all these negatives. Top exponent minus the bottom exponent. This will give us 5 to the negative 4 plus 7, which is 5 to the 3, which is 5 times 5 times 5, which is 125. Now, another way of doing this is to use this rule here where we move bases around in a fraction. Move bases top to bottom, bottom to top, if you just change the sign of the exponent. So I'll rewrite this one here. It's going to be 5 to the negative 4 over 5 to the negative 7. And then what I'm going to do is I'm going to move that 5 up, that 5 down. So when I do that, these exponents change signs. So we're going to have this fraction. Oh, let's get rid of that color. So we're going to have this fraction. Now this 5 is going to come down on top. So it's going to be 5 to the positive 4 on bottom and 5 to the positive 7 on top. And now I'm going to use the quotient rule. So I've got the division, 5 to the 7 over 5 to the 4. Subtract the exponent, so it'll be 5 to the 7 minus 4. That's 5 to the third. I still get 125 if I do it that way. Here in 13, we have a division again. So I'm going to do this one two ways. We could directly use the quotient rule by doing this. You write the base, the common base, top exponent minus the bottom exponent. All right, be careful, negatives. Top minus the bottom, right? Top minus the bottom. This gives us y to the 4 plus 7, so I get y to the 11. That's using the quotient rule. But I could use another rule. Here's what I could do. I could bring this 7 here, this y to the negative 7, I could bring that y up if I just change the sign of the exponents. So doing so will give us y to the 4 And now when you bring this up, the 7 changes from negative to positive, so you get y to the positive 7. And now I use the product rule, right, where I'm multiplying, so I add the exponent. So I'm going to get y to the 4 plus 7. I get y to the 11, just what I was expecting. So it doesn't matter which way you do it, just pick a way, and you'll get there.